factors that we had originally designed. So my take-home message is always test the theoretical model that you used when you created your test or your survey. It's more likely to work. This is cute, but it's kind of a mess. There's paths everywhere. And this was 9 correlated factors. And 9 of those 10 factors were replicated. So please, always test your model.
But what does mean PASA?
Sorry, say again?
The factor number 8, what does
Number 8, PASA, peer assessment, self-assessment. Sorry, you have to read the article in Teaching and Teacher Education. Multiple models of how latent factors relate to each other existing can be logically described. Selection depends on the theory and statistical fit, and we looked at how you could tell whether model 1 is better than model 2 by looking at the AIC value or looking at this chi-squared DF test. And we talked about this already, so I don't need to repeat that, yay. And we did this the other day, didn't we? So I don't need to repeat that, yay. So, here's an example of 3 models. The Louisiana model that was hierarchical, 7 factors. The New Zealand intercorrelated bifactor hierarchical, and then just the New Zealand correlated model of 9 factors. How many factors, how many items, what the chi-square value was, what the degrees of freedom was, the p-value for the chi-square, the df, the CFI, not very good, but the gamma hat's pretty good. So, you know, like 3 factors. This was weird because it's 9 factors. Well, no, it's actually consistent with everything we read. 9 factors is more than 3, so CFI didn't like it. But gamma hat said, hey, you know, it's okay. And RMSEA did like it, and the SRMR did like it too. So model 9 was better for New Zealand than the other 2 models. The exploratory factor analysis model and the model we found for Louisiana. So I always like you to go back to, I designed these items for this idea, these items for this idea. Test that first.
And do you find some conceptual differences between Louisiana and New Zealand?
In the article, the 2017 article in the International Journal of Research and Method in Education, we talk about this, why Louisiana and New Zealand didn't match up. And we put it down to mostly the assessment policy context of Louisiana is so different to New Zealand. All right. So, if you're going to go with a correlated model, test the alternatives. Test your structures. So, this is the hierarchical model. We've seen that. It's the first order of factors are explained by a higher order factor. If 2 or more factors are highly intercorrelated and have a shared theory or concepts, perhaps they have something in common. As subordinate factors, they explain the items better than allowing the items to go onto the higher order factor. It's much more restrictive. Factor 1 and 2 belong to factor 3 and do not have paths to factor 4, 5, and 6. It's much more restrictive than factor 1 is correlated with factor 2, 3, 4, 5, 6, 7, 8. Factor 2 is correlated with. And that's much less restrictive. It's a tighter specification, harder to make it fit. Here's the hierarchical syntax. What's different? So I changed the name, so I know what it is. Bad, ig, psi, tie. So all of that is exactly the same. The first part of the model is each of the factors. The second part of the model says irrelevance explains BD and IG. Improve explains SI and TI. Effective is CE. External is SF and SQ. That's all you need to do to create a hierarchical model is create a factor that explains the factors. It's that simple. I was impressed that it was that easy to do. So this is the model that we had that we published in Learning and Instruction. So irrelevance, exam, these 4 factors, and note, if you're going to create a diagram, put the factors in order that you want them to appear in the model. So if you want irrelevance to be at the top, put those first 2 in. So whatever you think, use your judgment as to what order they're in. It won't change the calculations, but it'll change the display. Any questions about that syntax? It's really quite elegant and simple.
And bracket is the same, we don't need anything extra.
You just use lavaan. Yeah, it says lavaan. Yeah, no, nothing extra. So you do the factor analysis. So the fit of this hierarchical model is a factor analysis of this model and that data set. Warning message I got. Oh dear, what can the matter be? lavaan warning. Some estimated latent variable, LV, latent variable, variances are negative. Oh no! Negative error variance, I don't want that. So, here are the variances, and you go, ding, there's a negative number. And that's the negative number for the scale IG. And you read across, standard error, 0.053. 053 times 053 is 10, and that 10 is bigger than 7. So the p-value is bigger than 0.05. It's 0.28, almost 29. Or, I can't read what number that is on the screen. 25. So you have 2 choices. Get rid of the factor and just have the items go to the higher order, or fix the negative error variance to a positive number. When I did this, I decided, oh bugger, negative error variance. And when I did it in Amos, the standard error was too big to fix. So I changed the model. I got rid of the IG factor. But remember, this is 617. I had a smaller sample when I first did this. And here's the visual check. Based on this plot, can you see where the negative error variance is hiding? It says it's IG, and when you follow back up, that number is 1.04. That's the warning, it's more than 1. Why is it more than 1? Because suddenly we have negative variance left over, and you can't have more than 100%. So my solution in the past was take away that. Have these items go straight up to here, which is what you've seen earlier this week. But according to this, where'd it go, IG? This could be fixable by saying, let the variance of IG be 0.005 instead of freely estimated. Fix it. So you can't get the error.
And how do you fix it? Do you write a command?
Yeah, you'd have to write a command. You're going to ask me, what is the command?
One line in lavaan.
Yes, it'll be 1 line, and it'll be something about, it'll be double tilde equals, no, it's just the single tilde, right, for the variance. double tilde is covariance, so 1 tilde will be variance. So it must be something like, IG, no, it'll be IG double tilde 0.005 times IG. I'm looking at him because he knows R and I don't. I know how to, this is why I like visual software, because then I can go, oh, there it is, fix. In Amos, it's just change it to 0.005. So what did we just say? Let's see, where did I put my pens?
Here, there's
Oh.
one.
Thank you. So, what did we say? IG tilde tilde 0.005 times or star IG. Is that right? Is that what we said?
Yeah, that's what we
Yeah,
just
but I
said.
think you need 0 before 0.2.
It's this one.
Maybe, but R is stupid. You and I know 0.005 is 0.005, but can you guarantee that R is smart enough to know that? I can't. So that's why he said put it in, and then I go, yeah, maybe you have to, because you know, it's R, it's stupid, right? It's literal. It doesn't understand humans. It's not supposed to understand humans. It doesn't even understand the numbers. You understand the numbers. Right. So so there are two solutions. Delete the factor, have the items go up here, or fix this to a positive value. You don't know how big it is, but you know it's positive. And then this loading will be 0.9999999. It'll be huge, but it'll be under 1. Which means
Can I ask you, but what does it mean that this variance is close to 0? So that means that this factor is explained by the higher order?
yeah. So that's conceptually what you're saying. So is it wrong to just say, well, let's get rid of it and just have the items explained by the higher order factor? So mathematically, well, at the time when I was doing this, I didn't really know about fixing it that, or the data said you can't really fix it that way. So, and if you do fix it that way, doesn't it mean the same thing? You're just creating extra noise by insisting on a factor. The beauty of having a factor is that you can then talk about there's a score, because people are interested in scores. Readers of your research don't want to know how elegantly you solve the solution. They want to know, so what's the point? So that was remove the bad factor. So now BD is here, and irrelevance now is BD plus the 3 IG items. So instead of keeping them up here, I move them here. Right? It's that simple. It's that easy. If only you believe it. You know, it's actually not hard to do. It's just kind of boring to do. But if only you just we all want voice-operated command systems, you know? Hal, open the door, Hal. Do you remember that movie? I assume you guys did. 2001: A Space Odyssey. The computer HAL on the spaceship, and they could talk to it. HAL opened the door to, or wouldn't open the door to let him back in. And at the end of the movie, he's going, HAL, what are you doing, Dave? Dave? Anyway, so what did we get? We've got irrelevance is bad and ignore. And there were no warnings here. There were no warnings here in the variables. And everything is starting to look sweet. These are the correlations. The loadings improved to 170, 121. The standardized loadings are over here. Looks like things are pretty good. So this is the model that got published in a book chapter in 2009. Did we fix the issue? Variances, nothing is negative. Yay. But that one there is a 2% probability that it could be 0 or less. No, 2%, no. 2 100ths of 1%. Right? Like 0.002. 2 chances in 1,000 that that value of, what is it, 0.125 is less than 0. But it isn't, so we'll carry on and pretend it's fine. Everything else. Notice it says 0, but you know that it's not really 0, right? Everybody understands that it's not 0, it's just so small, it may as well be 0. And here's your covariances now. Irrelevance, negative, negative, negative. Improvement, positive, positive. Affective, positive. So it works. So what I did, this is my my general strategy for the trying to find the response style. People who say, yes, it's good for this, should say it's not irrelevant. It's not bad, and I don't ignore it. That's what they should say. It's going to help me improve, so I don't ignore it. I don't think it's bad. So if this is negative, then I know they weren't cheating. But of course, there is variation in the population. Some people will think that assessment is evil and can't help anyone, right? Maybe it's a luxury of developed countries where we can go, stupid. I'm smarter than this exam. They don't need an exam to know I'm smart. Fit. Blah, 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 blah. 496, 92, that's 5 into 9,000. 5 is pretty high on a ratio basis. TLI, CFI, 88, 87. And where was my RMSEA? Here we go, RMSEA 0.06, 0.057 to 0.64. Yeah, ISMR 0.66. Yeah, okay. With the gamma hat, you might go, yeah, this model's okay. And this is what it looks like in lavaan plot. All your factors in predicting 2 factors, and this factor. Let's put these items as far apart as we can, so it's really ugly. And this is the lavaan plot diagram, and it makes you wish for the ugly plot, because no, where, okay, there's CE, there's PE, there's TI, there's SI, there's, maybe it's not as bad as I think, you know? So learning to get the right plot out of lavaan or out of R. Maybe you need to take a little course on how to draw good diagrams in R, because I don't know. Here's what my artist drew as a human. He's a computer graphic artist, and I paid him to draw this as a beautiful thing, and this is what I came up with. You get the items, you get the loadings, you get the structure, you get the correlations, and it's all just very beautiful, right? That's what an artist can do using a Mac, doing blah, blah, blah. And it's just, here's some money, fix it for me, right?
But you can use art to draw this diagram manually, right?
What? Next week, ask Maxime for a course on how to make my beautiful drawings in R. I'm sure R can do everything, I'm just lazy and there it is.
Especially if you pay.
Yeah, I mean, and also I'm old, you know? I've had my Beatles' birthday, so this is just too hard for me to learn. Do you know what Beatles' birthday is? You know what the Beatles are? Oh, good. Will you still feed me? Will you still need me when I'm... Do you know the line?
No.
No.
When I'm 64, dee-da-da-dee-da-da-dee-dee-dee, bum 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 ba-da-da-dum. So I've had my Beatles birthdays. Hierarchical models are elegant but difficult to fit statistically and prove theoretically, and the latter is the most important thing about it. Bifactor. This is becoming more and more, in my mind, a really robust solution. In multidimensional scales, it could be that items are predicted by more than their intended factor, especially if the factors belong to a whole. They're subscores. And to identify this bifactor analysis, analysis identifies the two predictors and their relationship to the items. The total factor is usually called general or common. You could call it the math or the attitude scale. And some factors are usually called unique factors. So this article here. My colleague, a Spanish researcher, developed a questionnaire in which she said, every item is explained by two things. This is her conceptual model. So it's not an artifact of the data, it's an artifact of her theory. Her theory says, these items are about assessment for teaching. These items are about learning. These items are about certifying people, giving them checking to make sure they pass exams and get certification. And this is about accountability of schools. So she clearly identified the content difference of the items. But then she said every item also serves either a formative improvement function or a function of societal control. So you can see these two factors explain about half of the items in each content factor. So her whole way of thinking about a statement was, what's it about and what's it for simultaneously? And I have to say, when we got the data from her, we tried just standard factor analytic techniques, and everything started falling apart, and none of it made sense. And I remember saying, well, what if we go back to her model and test the model? And it worked. That's why I constantly harp on, you had a model, test it, you might be right.
Well,
Yes.
but I think that this questionnaire was designed for this matrix structure because
Yes.
we have content and formative social.
This is the ideal way of approaching bifactor, that you actually design every item is explained by two things. And that, as Maxime said, a kind of matrix, that every item is explained both by its content and by its function or purpose. And this is a real reason to use bifactor modeling. So when you're creating a test and you say, well, all of them are math, so there's a general factor, but these ones are algebra, these ones are geometry, these ones are different subparts. That's another legitimate matrix way of looking at your data. So that is the real reason. But some people go, well, I tried my unique factors and, oh shit, it still doesn't fit very well. Let's try a bifactor model, and out of convenience, and oh great, the model's improved. I corresponded with Keith Marcus in New York about this, and he said, yeah, this is the real reason to do bifactor, because you have a matrix way of thinking about each response, each stimulus that they're responding to. And some people don't. So this, I was very impressed when we said, well, let's go back to the drawing board, what she actually drew, test it, and it works. In fact, there's a later study where we replicated that model with a new sample, and it still works. So this is, in this book chapter, Anka Vickers, who works at CITO in Holland, She took my questionnaire and she ran it because she was studying bifactor modeling, and she ran it in this model. And we tried to get it published in a journal, and the journal said, oh, the RMSEA is too high, it's 0.10. We're not interested. So I was editing a book at the time, so we stuck it in the book. Fortunately, it was reviewed by Dennis McInerney and Greg Lim, so it wasn't just, I'm the editor, so you must put this in. It was, check it, make sure it's okay. And she ran it as 8 and 7 factors with a general factor, and she found it didn't work. But she ran it as 4 big factors and a general factor, and it did work. And the thinking there is, the content of all the items always is about assessment. So why are we surprised that the items have a general factor? I was trying to get away from a total score when I first designed it, but she said, well, wait a minute, all of these items are something about assessment, so let's try this bifactor model. I mean, it's what she was studying, and her supervisor asked me to let her have the data to do that.
And what bifactor and not second order?
Because, one, it was an alternative to what I had already demonstrated, that these things were second-order factors. And what she wanted to test, and what this tells you, is that the item is explained by its shared general content with everything else. We're all about assessment, but these ones are about this, and these ones are about that. And that way. So why not hierarchical? Because the hierarchical would be trying to explain these, and we were trying to explain the items. And also, this sucks up a lot more variance than just trying to explain these. You could correlate these, but you would leave out a lot of variance in these items. We'll get to practicing with this. My colleague Daniel Matos took the Brazil data and compared it to the New Zealand data, and he used the general and bifactor, and he and his colleague Cristiano Gomes did the number crunching, and I kind of looked on and went, wait a minute. And you can see one of my things I hate is evil. They did this in M+, so maybe M+ makes prettier diagrams than, or you think it can be done as pretty. And so they found 3 factors, and then these items were only explained by the general factor, and to make it work, they had to put this correlation in. And I still think you should get rid of one of those items.
Did they try to get rid of?
I can't remember. This is coming out at the end of the year, and we did this 4 years ago. Right? You know the process? You write a study, you submit it, they go, no, we don't want it. So you submit it somewhere else. They go, no, we don't want it. Those were the American journals because it's not from America data. And then, oh, okay, this is a Brazil data, Brazil journal. And they say, oh yeah, sure, that's interesting, but this is confusing and this is confusing. And by the time and then they go, it's accepted, but we're not publishing it until November 2019. So
It is,
takes forever.
yeah, it's strange that the same inventory gives a route to publishing very different articles with different models. It's like
The reason for that is, one, this is 2 data sets, not from 2 different contexts rather than 1 data set. And 2, we use the WLSMV estimator rather than the ML estimator. So part of the objective of the study was to say, is it better as WLSMV or ML?
I understand, but if I would be a student who is doing a literature research, literature review, and I found your articles, I would be confused.
Yes, you would be. Unless you understand the power of context. If you don't, and we try in every article to make clear what the context is, and then if we're comparing, we go, gee, this is not the same, and we think it's because... And so the constant message in my research is context really matters. And Brazil and New Zealand are really different places for higher education.